I am Dr. Himanshu Sarkar. Uh, welcome all the viewers to my YouTube channel. In my last two lectures, I had already given the thermal conduction of heat of class 11 section. This is very much helpful for the class 11 ICSE, CBSE and all other boards. Today, I will discuss in continuation of that thermal conduction. I will discuss thermal resistance. Before that, I request all the viewers to subscribe my channel so that all of you can get my video information for the next classes. So, in my last classes, what I discussed, just to remember, just to know what is the thermal conduction, the mode of heat transfer by three modes, that is conduction, convection and radiation. I am discussing the conduction of heat. I discussed in my last class, just again, I am just in short I am discussing. That is the conduction of heat. Last class what I told you, this is the rod, this temperature is theta 1, this temperature is theta 2. I told you temperature theta 1 is greater than temperature theta 2, and this is the thickness. I told you already what is the meaning of thickness, distance between the two temperature difference zone. I consider last class Q is equal to K A theta 1 minus theta 2 T by X. This K, Q is the heat flow, K is called the thermal conductivity, A is the area of cross section, theta 1 minus theta is the temperature difference, T is the time, and X is the thickness, and Q is the heat flow. In my last class also, I discussed what is the dimension of K. K is called the thermal conductivity. What is the dimension of Q? Q means what? Heat energy. So, dimension of Q is nothing but the energy. So, Q should be what? That is m L square T to the power minus 2. All you know the dimension? Mass, length and time, and temperature theta and current A. All are the fundamental quantities. So, that is equal to what? K into A is what? L square into this theta. Theta is the dimension of temperature. T is the time, that is into T by X means L, that is the length. So this L square cancel out. So I can write down K is equal to what? M L T to the power minus 2 by theta into T. That is equal to what? M L T to the power minus 3 theta to the power minus 1. That is the dimension of K. Dimension of K is what? That is equal to M L T to the power minus 3 theta to the power minus 1. That is the dimension of K. Q means again heat energy, M L square to the minus 2 energy dimension. All you know, K is the thermal conductivity, A is the area, L square. Then this is a theta, this is a time T by L. So L square cancel out. K is equal to what? M L T to the power minus 2 by theta into T, M L T to the power minus 3 into theta to the power minus 1. After this, I discussed in my last class. Follow my last class note, you will get it. Okay. Now today I am discussing what is called the thermal resistance. All you are familiar with the term resistance. Where you have read it, that is in the current electricity. You know by the Ohm's law, V2 minus V1 is equal to IR, V2 minus V1 is equal to, all you know from the Ohm's law, all you know, V2 minus V1 is equal to I into R. V2 minus V1 is called potential difference. I is called current and R is called resistance. So V2 minus V1 is called potential difference. Potential difference. Then I is the current and R is the resistance. All you know. So R is the resistance in case of the current electricity. But you know there is a similarity between the current flow and the heat flow. Why heat flow? Due to the temperature difference. Why current flow? Due to the potential difference. So I can give you some idea regarding the analogy of the current flow equation and the heat flow equation. Okay. So now what is the heat flow equation? That is Q by T, that is equal to what? Ka theta 1 minus theta 2 by X. Q by T is called what? Rate of heat flow. That is called heat current. Q by T is called heat current. So from this equation you can write down Q by T is equal to theta 1 minus theta 2 by X by Ka. That is your equation number 1. Q by T, that is the heat current, that is the temperature difference, by X by Ka. That is, this equation is called the heat current equation. That is the heat current equation. Heat current equation. But you know the current flow equation is what? Current flow equation is what? I is equal to V2 V2 minus V1 by R. That is equation number 2. What is I? I is the current. This is the current flow equation and that is the heat flow equation. Now, one thing, this Q by T, that means what? That is the rate of heat flow, and this I, these two are similar. Similarly, by analogy, why heat flow? Due to the temperature difference. Why current flow? Due to the potential difference. So, this theta 1 minus theta 2 and this V2 minus V1 are similar. So, if Q by T is similar to I, theta 1 minus theta 2 is similar to V2 minus V1. So R must be equivalent to X by Ka. As R is known as the resistance, so X by Ka is called thermal resistance. Now I am again discussing that is what? This Q by T is similar to I. That is by analogy. Okay. Theta 1 minus theta 2 temperature difference. Actually, why heat flow? Due to the temperature difference. Why current flow? Due to the potential difference. So this theta 1 minus theta 2 and V2 minus V1 are similar. So theta 1 minus theta 2 is similar to V2 minus V1. So this R must be equivalent to what? X by K. So we can write down this. So X by Ka is similar to R. R is called resistance. So X by K is called thermal resistance. So as R is called resistance, so X by Ka is equal to called RH. RH, that is called thermal resistance. Now I am stopping my class. For viewing the next video, I will discuss the series parallel connection. So to see it, please subscribe my channel.